We're going to begin this next part of the multiplication counting principle by focusing on the mathematics of lotteries. And I have two Wisconsin lotteries on this page. One is called All or Nothing, the other one's Badger 5. Let's start with the All or Nothing. All or Nothing is where one individual is going to select 11 different numbers from 1 to 22. The order will not matter. So if I was going to pick my ticket, which I'll put in blue, my ticket, I might choose to choose all the primes, 2, 3, 5, 7, 11, 13, 17, 19. Realize I have still a few blanks left. You know what? Let's go fill in with the cubes, the squares. 1, 4, and 9. Can't get 16 in there, ran out of room. And then the lottery would be drawn. For this particular situation, I've gone to random.org. I've selected I've set it up so that will give me the numbers. It's going to come back in order. That's not usually how a lottery plays out. They just put them in order for me. But how I selected the numbers does not have to match up to their order. So what I got was the following. I got 3, 4, 8. Well, I know 3 and 4. So here, let's write these down. We've got 3, 4, 8, 11, 15, 16, 17. And see, we also got 19, 20, 21, and 22. So I guess I've got a winner when I've circled the 3 here and the 4 over here. I got an 11. I've got the 17. I've got the 19. But after that, I don't see any other winners. I don't see 8 and 15 on my card. 16, I could have had the next square, but I don't. And 20, 21, 22, nope, those are not. So in this case, I had 5 correct. Maybe you could say 5 success. I had 6 wrong. Okay. So let's go now start doing the mathematics. All right. And for this particular problem, I don't need this anymore. We'll minimize that. It says, how many ways can you select the 11 numbers? Well, I had, in this particular problem, 22 numbers that I could choose from. I had 1 through 22. And since order does not matter and there was without replacement, this is a combination problem where I took 11 of them. Now, if I did the actual math, it would be 22 factorial over 22 minus 11, because that would be the NPR business. But then I would still need to divide that. Oops, that's a little too much. I just want that, move that over. But then I still have to divide that by an additional 11 factorial to remove the order, which means it was 22 factorial over 11 factorial, 11 factorial. I'm not going to do this every single time, but at least for this set of problems I will. And if I go to the calculator and I type in 22, and then I go to math and I move over to NCR, so there it is, an 11, I hit enter. I come up with 705,432 different combinations of selecting the 11 numbers. Now, the next question says, match all 11 winning numbers correctly. Okay, so these up here was the actual numbers, so I guess you could say those are the winning numbers. And if they were winning numbers, I guess I should have, associated green with that, but it's too late. We're doing it with red. And so there were 11 winning numbers. So I guess what I'm going to do is I'm going to select 11 numbers from 11. Now, we've learned this property in the last lesson. But if we did the math, we would see 11 factorial would be divided by 11 minus 11 factorial, and then divide that by 11 factorial. That would give us a 11 factorial on top, 0 factorial on the bottom, and 11 factorial on the bottom as well. The numerator and denominator 11 factorials cancel out. This is the same as 1, and lo and behold, we would have, there is only one way that you could have selected all the winning numbers. So, I guess if you wanted to know what the probability was, the probability of winning would have been 1 over 705,432. We're focusing mostly on the counting of this, but I figured we could at least mention that right now. Now this one says, well, how many ways can you match 11 winning numbers incorrectly? Well, if I wanted to go 0 for 11, I would be going 11C0, which I think you're about to see some very similar work, because I would be going 11 minus 0 factorial over 0 factorial, which again would be 11 factorial over 11 factorial 0 factorial. Only difference is the order is different. That's 1. This brings up that rule again where we talked about 11C11 is the same as 11C0. So kind of up here, every time I put a number in the correct team means it's a number that doesn't go into the incorrect team. And if, let's say, I have 5 correct numbers, they'll make up one team, and that means I'll automatically have a team of 6 incorrect numbers. So I guess I'm saying is 11C5 is going to equal 11C6. And that's kind of what I'm getting down to here. I'm going to say if I match 9 of the 11 winning numbers correctly, and I'm only looking at the winning numbers, I'm going to simply go 11C9, and that works out to be, there we go, 11 math NCR, and I go 9. 55 different ways of doing this, and right now I'm ignoring the losing numbers, so I can emphasize that if I would have done this as 11C2, I'm just going to hit enter and put 2 in this spot. These are the same thing. So I'm really emphasizing that one particular rule, that every time you make up a team of a certain number of individuals, you're making up essentially another team of those non-selected. So 11C9 equals 11C2. Thanks to the magic of editing, I'm picking up right where we left off here after my little technical incident. And it says, how many numbers from 1 to 22 should be selected if you want the greatest number of ways to select a ticket? So I'm designing a lottery. I have 22 numbers. And the question is, I want to make sure that this is as tough as possible with just 22 numbers. How many ways should someone have to pick the numbers? How many group of numbers should they pick so that it's the most number of combinations? Before I tell you the way to do it quickly, is I just want you to understand that some people might think at first, hey, you should pick all 22 numbers. Here's the issue. If you pick all 22 numbers, you're going to create a group of 22, which means you're also creating a group of 0. And we know that if you pick no numbers, there's one way of doing it, which means if you pick all the numbers and it's in one group, you only have one way of doing it. And so that's not the way to attack this. In fact, what you're going to find out is the farther out you are from the middle, the less number of combinations that is. So that's right. If you would take half of your 22, which in this case is 11, that would be the largest number of combinations, which in fact is exactly how this game is designed. 22C11, the 705,432 different combinations, is the max for this particular problem. And we'll keep practicing that as we continue on. But we'll need some more examples, and for that, I'm moving on to a new lottery game in Wisconsin, which is called Badger 5. So let me slide that up. And Badger 5 says we're going to select 5 different numbers from 1 to 31. Order does not matter. So what I've decided is I'm going to write down my squares. Just so you understand, so if this is my ticket, it does not matter how I write them down. I could write it as 1, 4, 9, 16, and 25. But if I wanted my 4 to come at the end and put my 25 here, I could do that. I could put my 16 here and my 1 over here. Again, the reason I'm showing you these rearrangements is because this is a group of numbers. Order does not matter, and therefore that particular looking ticket is going to be the same as if I would have just gone 1, 4, 9, 16, 25. So I went back to random.org. I asked it to create a lottery ticket for me, and the lottery ticket came up with is 1, 3, 8, 26, and 29. So let's go ahead and write those numbers down. Maybe I won't put them in the order that they are. Maybe it actually came up as 3, 8, 26, 29, and 1. So that was the actual numbers. And one more time, we'll just verify it. 3, 8, 26, 29, and 1. Yep, that's good. All right. And so let's see which ones actually matched up. I got a 1, and that's it. So I had 1 correct and I had 4 wrong. Well, we're going to go a little deeper into the mathematics of the lotteries because now we're going to actually start putting our winning numbers and our losing numbers together because that's what actually makes up a card. If you recall my problem up here, I just focused on getting 9 numbers right out of 11 or getting 2 numbers wrong out of 11, but I didn't actually put those together. Well, now I am, and so first off, we probably should figure out how many ways could you select 5 numbers from the 31, and so that really will just be 31C5, and I will put that into the calculator. So 31 math, oops, over here, 5, hit enter. I come up with 169,911 different combinations or possible lottery tickets or possible outcomes that can come out of the system. So let's now focus on the 5 winning numbers. Remember, the 5 winning numbers in order were 1, 3, 8, 26, 29. There were 5. And so if I'm going to do the math, and I'm going to be able to select 3 of them. So just in case you're trying to figure out what I'm talking about, maybe my new lottery ticket would have been, maybe I had a different lottery ticket that would have said instead of 16, 25, 9, 1, 4, maybe it would have gone 16, 25, 8, 1, 3, and I could select these 3 winning numbers. Well, 5 NCR 3 works out to be 10. All other numbers are losers in this case. So I'm going to say I have 26 losing numbers. And what I realize is that my lottery ticket is made up of 2 losing numbers here. So 26C2. If I go 26 math, all right, and I go NCR and I go 2, I come up with 325 different ways I can lose. Well, what is a lottery ticket truly made up of? It's made up of winning and losing. And in this particular case, every time I come up with a winning combination of 3 numbers, I have to match it up to a combination of 2 losing numbers. So if I had 1, 3, 8, I might have had to match it up with 2, 4, but then I could have a 1, 3, 8 that matches up with 2, 5, and a 1, 3, 8 that matches up with 2, 6, and that gets me much. So in the end, if I want to actually figure out how many ways I could actually have gotten 3 out of the 5 numbers and also 2 out of the 26 losing numbers, I would have to go 5C3 times 26C2, which means I'm coming up with, in this case, 10 times 325, which means I'm coming up with 3,250 different ways I can have a lottery ticket have 3 wins and 2 losses. And that's how I would go about figuring out my probability. So the probability of getting 3 out of 5 in this particular game would be literally 3,250 over the 169,911. And if that probability is good enough or hard enough, they may award me a prize for getting 3 out of the 5. So let's look at the last 2 questions. The probability of winning the jackpot is the same if how many numbers, and not 5 out of 31, were initially selected and correctly matched. Okay, so let me explain what we're trying to do here. I want to create a new lottery game, except I don't want it to be 31C5, and yet I would like it to still have 169,911 possibilities. So this is maybe what I had before, 31C5. I want my 169,911 possibilities, but I want to do my ticket differently. I want it to be 31C what? And it's pretty easy. Every time you make a group of 5, you're also making another group of 26 because 5 are in this group, 26 in the other one. So in this case, 31 NCR of 26 is also 169,911. Remember, I get this number by going 31 minus 5. And that's where I get my 31C26. So the answer to my question is, I could have just made a game of 26 numbers out of 31. Because that would be hard to make sure people are actually, did they win or not? Go with the smaller number, 5. It's easier for them to determine if they're their own winner. And then it says the most difficult probably to win would be to initially select and correctly match how many numbers from 1 to 31. Basically, which one's going to give me the most number of combinations? And so that kind of goes back to my question right here. Problem is, if I take 31 and I divide it by 2, I get 15.5. Well, you can't take fractional or decimal values when you're doing combinations. So I'm telling you that the best way of doing it is select 15 or 16, because if I would go 31C15, I would have 300,540,195 different combinations, which would make this a pretty darn challenging lottery to win if I had to get all the numbers. But I could have also played the exact same game if I had 16 numbers, which is 31C16. So in this case, the correct answer is 15 or 16. Another Wisconsin lottery is actually a multi-state lottery called Powerball. And we're going to select 5 different numbers from 1 to 69. So if this is going to be my ticket is going to use, let's do the squares again, except this time let's change it up a little bit. Let's go 9, 16, 25, 36, 49. Would have been nice if I could have gotten 64 in there, but I started with 9, so that's going to what it's be. But I also have to pick a Powerball number, and I want to be clear here. This particular Powerball number can be a duplicate of one of my first 5. I just cannot pick my first 5 the same number twice. So if I wanted to pick 25, great, I will. If I wanted to pick 36, I could, but I don't have to. So in simple fact, I'm going to pick another square. I'm going to pick 4. And that's going to be my Powerball number. And the ticket that came up is 10, 11, 29, 49, 61, and 17. So let's write that down. 10, 11, 29, 49, 61, and my Powerball number was, ta-da, 17. Okay, well, I got one number correct. So I had 1 right, 4 wrong in the first batch. So that would be actually, maybe it applies over here. But then I had 0 right and 1 wrong over here. And all that would have to be figured out when I was doing the situation. But let's first figure out how many ways could I select 5 different numbers and a Powerball number. And for this, I will do some color coding. So for instance, right here, we're going to make these red, and not because of wrong, it's just going to be that I'm going to select, all right, select 5 from 69, which would simply be 69C5. And then over here, let's put this in green, I'm going to select 1 from 26, 26C1. And the multiplication counting principle says I'm supposed to multiply. So if I actually do those numbers, what I come up with is 292,201,338. All right. And again, to emphasize on the calculator, I'll type in 69C5. There's that number of ways. Looks like 11,238,513 ways just to get the first 5 numbers. Then I'm going to do 26C1. Now, I already know what that is because I'm only choosing one number out of 26. That should just be 26. And so if I take that number and multiply it by the 26, there's my 292,201,338 different possible Powerball tickets. So let's not quite win the Powerball. Let's get all the way all excited that I've got 5 out of the 5 numbers, but I don't actually get the Powerball. So in this particular case, I only have 5 numbers to get my winning numbers from, and I have 5C5. Well, I already know that that happens to be the same as 1. There's only one way to do that. Then over here, I have to choose, there are going to be 25, okay, 25 losing Powerball numbers, okay. So I'm going to go 25C, and I'm going to choose one of those. Well, I've already learned that when you take 1 from any number of numbers, it's just a number, so 1 times 25. So I should expect there to be 25 different ways I could have gotten the first 5 numbers, only to lose it with the Powerball. On the other hand, maybe I got the Powerball, but my one wrong was in the set of 5. So for that math, I'm going to have to take my 5C and do the 4. There's my 5 number. I have 5 of 69 are winners. But then that means 64 of 69 are losers. So when I do my math, I have to go 5C4 times 64C1. Here's my 5 and 64 are my 69 numbers. 4 come from the winning, 1 comes from the losing. Now 5C4 is the same as 5C1. And 5C1 happens to be 5. 64C1 is, well, 64. So if you multiply those together, you will come up with 320 different ways. Over here, let's go ahead and multiply that by the 1 winning Powerball, and I got the 1 winning one, which means I should be multiplying this by 1. And it's getting a little hard to keep track of all my color schemes, but in the end, I could have done that as well with 320 different tickets. And since I see that this was not in green, we will make a quick adjustment to that right now and put that in green as well. And so this is how I'm going to build my lottery ticket. So let's get a little farther down. If I have 3 winning numbers and I also match the Powerball, the math is going to go as follows. It's going to go 5C3, that's my winners, times, and then it's going to be 64C2. So there's my 5 numbers total. 3 from the winners, 2 from the losers. Then I will multiply that, and it did win or match the Powerball, so that is not green. 1C1. And if I type that all into the computer, I found that out to be 20,160. And finally, if I'm going to match one of the 5 numbers but not the Powerball, that means I've got 1 number from the 5, but I have 4 numbers from the 64, and I still have to multiply that by 1 number from the 25 that was not successful. Since we haven't used the calculator in just a couple of minutes, let's actually do this on the calculator. 5C1. That's going to actually be 5, but I'm going to do all this in one fell swoop. 64, oops, too far. C4, that one I do not know off the top of my head, but then I have to still multiply that now by how my Powerball played out, which is 25C1. That one I can figure out because that is just 25, but again, I'll type it all in. And then you find out that if you just want 1 winning number out of the 5 and not even get the Powerball right, you have 79,422,000 possible tickets out of the 292,201,338. So when we move to Mega Millions, really not much is going to change, okay? The way we select our numbers is going to change. which is going to affect our probability. So again, if I highlight this as the red section, and I say how many ways can I select 5 different numbers, that math would be 70C5. And if I'm going to highlight the mega ball number, which can be a duplicate of this, but these can't be duplicates of each other, I could say that technically I have 25C1, and I did the math already, and this game is actually a little harder to win because there are actually 302,575,350 different combinations. If I'm going to do 4 of the 5 numbers, my first part of the ticket, I will go 5C4 because we have 5 winners. But that also means of the 70 numbers, 65 would be losing numbers. And so I'll need to multiply 65C1 because that's going to represent that part of the ticket. And then I will multiply this by, if I'm not getting the mega ball, then it's going to be 24. I almost did 25, but it's 24C1. I was getting that mixed up with Powerball, 24C1. And that works out to be 7,800 in different ways you can get 4 of the 5 numbers and still not get the mega ball. If I wanted 3 of the 5 numbers but not the mega ball, then it will be 5C3 times 65C2 multiplied by, and it's still going to be 24C1. And you're going to find out that is more likely to happen than the last opportunity. So 499,200 possibilities. Well, let's say I wanted to get 2 of the 5 numbers right, and I even matched the mega ball number. How does that play out? Well, that would be 5C2 being multiplied by 65C3. 70 numbers, there's my 5 numbers. 2 come from the 5 winners, 3 come from the 65 losers. We'll multiply that, and since there is only now 1 winning number, and I'm going to grab that 1 winning number, you find out mathematically that that works out to be 436,800. So it's actually harder to do this than it is to do that. And finally, well, can you go 0 for 5 on the numbers and not even get the mega ball? Literally, your ticket goes completely unmatched. Well, that math is pretty straightforward. 0 numbers out of 5 times 5 numbers out of 65. And then because you have 24 losing numbers, and you have to select one of those losing numbers, when you work that out of the 302.5 million tickets, 198,237,312 of those tickets will meet exactly that condition where you could not get a single thing right. And that brings us to the end of our lottery lesson.